Today we are going to cover section 10.2, graph y equals ax squared plus bx plus c. Example 1, find the axis of symmetry and the vertex. Let's consider the function y equals negative 2x squared plus 12x minus 7. Y equals negative 2x squared plus 12x minus 7. Part A, find the axis of symmetry of the graph of the function. Find the axis of symmetry of the graph of the function. A simple formula for finding the axis of symmetry of the graph of a quadratic function, an equation in which the highest power of the variable is 2, is the formula x equals negative b over 2a, in which a is the coefficient of the variable term, so in this case a is negative 2, b is the coefficient of the variable term, in this case it's positive 12, and even though it's not in this formula, c is the constant, the number without the variable. So substituting in for b and a, that's going to be negative 12 over 2 times negative 2. So that's negative 12 over negative 4. The two negatives cancel out. 12 divided by 4 is 3. So the axis of symmetry is the vertical line x equals 3. The line going up and down that goes through 3 on the x-axis. And now let's look at part B, which is find the vertex of the graph of the function. Find the vertex of the graph of the function. So the vertex is the highest point or the lowest point of the parabola, depending on whether the parabola opens upwards or downwards. In this case, the parabola formed from graphing the quadratic function y equals negative 2x squared plus 12x minus 7 opens downwards. It's an upside down U because the variable squared term is negative 2x squared. Okay, so therefore there's a maximum point in the parabola, a highest point, and to find that vertex, we substitute in 3 for x in the function. Y equals negative 2x squared plus 12x minus 7. So substituting 3 in for x, that's going to be negative 2 times 3 squared plus 12 times 3 minus 7. According to PEMDAS, we do E for exponents before M for multiplication, or A for addition, or S for subtraction. 3 squared is 9. Negative 2 times 9 is negative 18. 12 times 3 is 36, minus 7. Addition and subtraction are equal in importance according to PEMDAS, so if you see both in the problem, you do whichever comes first as you go from left to right. Negative 18 plus 36 is 18. 18 minus 7 is 11. So 11 is the y-coordinate of the vertex. And then the x-coordinate of the vertex is 3, which we found in part A. So there's the answer to example 1, but just to help you visualize what's going on in the graph of the function, and to help you understand exactly what axis of symmetry and vertex mean, let's do a sketch of the graph. using the answers in parts A and B. Let's first plot the vertex, 3, 11. And let's not use tick marks, we're just making a rough sketch. Let's say 3 is here and 11 is here on the y-axis. And we're graphing y equals negative 2x squared plus 12x minus 7. And like I said, the parabola opens downwards as an upside down u because the variable squared term is negative 2x squared. The axis of symmetry is x equals 3. The vertical line going through 3 on the x-axis. It's helpful to, so there's basically how the graph looks like, but to really make a good sketch, you should know what the x and y intercepts are. To find the y-intercept, you can substitute in 0 for x and solve for y, because everywhere along the y-axis, x is 0. So negative 2 times 0 squared plus 12 times 0 minus 7 is negative 7, so it crosses the y-axis at negative 7, so let's fix that graph to go through negative 7 on the y-axis, which is, let's say it's about here. And to find the x-intercepts, you substitute in 0 for y and solve for x. Because everywhere along the x-axis, y is 0. But I don't think that, I'm pretty sure that quadratic function is not factorable, and you have not learned the quadratic formula yet. So let's not worry about the x-intercepts. But we do know it goes through negative 7 on the y-axis. All right, so there's a rough sketch of the graph of y equals negative 2x squared plus 12x minus 7. Now let's look at example 2. Oh yeah, and as you can see, the line x equals 3 is the axis of symmetry because half of the graph is on the left side of that line and the other half is on the right side of the line. And each half is mirror images of each other. I didn't draw it perfectly, but yeah, x equals 3 is the axis of symmetry. Okay, example 2, graph y equals ax squared plus bx plus c. Let's use the formula we learned in example 1, x equals negative b over 2a, to find the axis of symmetry. And remember, whenever you're given a quadratic function or equation, meaning that the highest power of the variable is 2, the coefficient of the variable squared term is a, the coefficient of the variable term is b, so it's negative 6 in this case, and the coefficient and the constant, the number without a variable, is c. So positive 2 for this equation. So let's substitute in for b and a in the formula. That's going to be negative 6 over 2 times 3. The two negatives make a positive. We get 6 over 6, which equals 1. There's the axis of symmetry. The vertical line, x equals 1. And now to find the vertex, which means the highest or lowest point. This time the vertex is the lowest point on the parabola because the variable square term is positive, so the parabola opens upwards. It's a U shape. So there's a lowest point but no highest point. All right, so to find the vertex, we substitute in 1 for x and solve for y. That's y equals 3 times 1 squared minus 6 times 1 plus 2. And follow PEMDAS. Do E for exponents before M for multiplication, or A for addition, or S for subtraction. So that's 1 squared is 1, 3 times 1 is 3, 6 times 1 is 6. Addition and subtraction are equal in importance, so if you have both in the problem, do whichever appears first as you go from left to right. 3 minus 6 is negative 3. Negative 3 plus 2 is negative 1. So the vertex is, or the lowest point on the parabola, is 1 comma negative 1. And we got 1 from finding the axis of symmetry. All right, so now let's, before we can graph it, this time we're going to do a little more than a sketch. We want to get some more detail on the graph, a few exact points, not just the correct y-intercept and the correct vertex. So, but I'm going to erase most of what I have here, except for the axis of symmetry and the vertex, so that I can make room for the table. So our equation was y equals 3x squared minus 6x plus 2. The rule of thumb is you need to substitute in 2 numbers for x that are less than the x value obtained in the axis of symmetry. So let's substitute in 0 for x, which will also give us the y-intercept, which is an important point on the graph, showing you where the graph crosses the y-axis. And then the next whole number x value less than 1 would be negative 1. All right, so substituting in 0 for x, that's y equals 3 times 0 squared minus 6 times 0 plus 2. 0 squared is 0, 3 times 0 is 0, and then 6 times 0 is 0, so we get positive 2. Y equals 2. So that's the point 0, 2. Anytime you have y equals a variable squared term, and then a variable term, and then a constant, the y-intercept is going to equal the constant. Now substituting in negative 1 for x, that's y equals 3 times negative 1 squared minus 6 times negative 1 plus 2. Negative 1 times negative 1 is positive 1. 3 times 1 is 3. Negative 6 times negative 1 is positive 6. And we're going to get y equals 11. So when x is negative 1, y is 11, which gives us the point negative 1, 11. Okay, so let's now graph. All right, so making our graph, I'm going to make some more room here just to make sure I have plenty of room. The point 0, 2 on the graph, negative 1, 11. We have the axis of symmetry, which is x, the vertical line x equals 1. And we have the vertex, the lowest point on the graph, which we found a little bit earlier is 1 comma 11, or 1 comma negative 1, I'm sorry. Okay, so let's go ahead and graph this. I am going to make sure that I have 11 tick marks on the positive y-axis. Actually, I'm just going to go up by 2. Let's make this a little bit easier. 2, 4, 6, 8, 10, 12. And I'm going to just go up by 1 on the x-axis. And I'll have 4 tick marks on each side. -1, -2, -3, -4. Okay, so yeah, I'll put 4 tick marks on the negative y-axis. The point 1 comma. Okay, let's first things first. So axis of symmetry, dotted line, because that's not actually part of the parabola, the graph of y equals 3x squared minus 6x plus 2. All right, so 1 comma -1, the lowest point on the graph, that is right here. The parabola opens upwards because it's the variable square term's positive. And we have the point -1 comma 11 on the graph, right here. And the point 0 comma 2 on the graph. There's the left half of the parabola. And the line x equals 1 is the axis of symmetry. So we reflect the left half of the graph on the line x equals 1 to produce a mirror image right half of the parabola. Let's first reflect the point 0 comma 2. So reflecting it on the dotted line, x equals 1, you rotate it in the opposite direction. So instead of being 1 to the left of the dotted line, it's going to be 1 to the right of the dotted line. So we have the point 2 comma 2 on the parabola. And then we have the point -1 comma 11 right here, which is 2 to the left of the axis of symmetry. So reflecting that in the opposite direction, it's now going to be 2 to the right of the axis of symmetry. So 3 comma 11. If I was using graph paper, this would be easier. I highly recommend using graph paper. And it goes on forever in that direction. All right. So that's the end of example 2. Example 3. Find the minimum or maximum value. Tell whether the function f of x equals -3x squared minus 12x plus 10, -3x squared minus 12x plus 10, has a minimum value or a maximum value, then find the minimum or maximum value. So I've already discussed this, but let's get some more practice with this. So does it have a maximum or a minimum value? And what is it? First, find the axis of symmetry, or the x-coordinate of the vertex. So that's gonna be obtained by using the formula x equals negative b over 2a. Remember, a is the coefficient of the variable squared term, b is the coefficient of the variable term, and c is the constant. So that's going to be negative 12 over 2 times negative 3, which is the two negatives up here on the top make a positive. So we get 12 over negative 6, which is negative 2. Oh, yeah, we can immediately tell, without even using the formula, that it's going to have a maximum value because the variable squared term is negative. So the parabola opens downwards. It's an upside down U. So it's going to have a maximum value. And we just found out that the x-coordinate of the maximum value is negative 2, and the axis of symmetry is x equals negative 2, vertical line. Now to find the y-coordinate of that maximum value, which is a vertex, we substitute in negative 2 for x in the equation given to us in the problem. By the way, f of x is the same thing as y. So y equals negative 3 times negative 2 squared minus 12 times negative 2 plus 10. Negative 2 squared, negative 2 times negative 2 is positive 4. Negative 12 times negative 2 is positive 24. Negative 3 times 4 is negative 12. Negative 12 plus 24 is 12. 12 plus 10 is 22. So our vertex is a maximum value, the highest point on the parabola, which is negative 2, 22. And for you visual learners, let's do a sketch of the graph. In fact, let's do more than a sketch. Let's graph this, just so we can get more practice with that. Let's make room for a table. We have our axis of symmetry, x equals negative 2. Our vertex, the maximum point, the highest point on the parabola is negative 2, 22. And now let's pick two x values, two whole numbers less than negative 2. So negative 3 and negative 4. And let's also substitute in 0 for x to find the y-intercept. That's an important point. Into the equation given to us in the problem, y equals negative 3x squared minus 12x plus 10. Y equals, substituting in negative 3 for x, that's y equals negative 3 times negative 3 squared minus 12 times negative 3 plus 10. Negative 3 squared, negative 3 times negative 3 is positive 9. Negative 3 times 9 is negative 27. Negative 12 times negative 3 is positive 36, plus 10. Negative 27 plus 36 is 9. 9 plus 10 is 19. So when x is negative 3, y is 19. So we have the point negative 3 comma 19 on the graph. And then substituting in negative 4 for y, that's y equals negative 3 times negative 4 squared minus 12 times negative 4 plus 10. Negative 4 times negative 4 is positive 16. Negative 3 times 16 is negative 48. Negative 12 times negative 4 is positive 48. Plus 10, we get 10. So the point negative 4 comma 10 is on the graph. And substituting in 0 for x, that's y equals negative 3 times 0 squared minus 12 times 0 plus 10. We're going to get y equals 0 minus 0 plus 10, which of course is 10. So the point 0 comma 10 is on the graph. All right, so I want to move these points up here, negative 3 comma 19, negative 4 comma 10, 0 comma 10. Let's go ahead and graph. Well, okay, I guess I have enough space to graph without needing to erase anything, so I didn't really need to move the points, but that's okay. Now I have all the important information in the upper left-hand corner of the board. Okay, so I am negative, so we have, let's put 4 tick marks on each side of the x-axis. We have the axis of symmetry, x equals negative 2, which is a vertical line. Anytime it's x equals a number, it's a vertical line. So going through negative 2 on the x-axis. And then for the y-axis, the highest y value that we need in our sketch is 22. Let's go up by 2, 2, 4, 6, 8, 10, 12. You know what, let's go up by 4. All right, so 4, 8, 12, 16, 20, 24. And let's put a few tick marks on the negative y-axis. And let's go down by 4. Negative 4, negative 8, negative 12, negative 16. All right, so we have the point negative 2 comma 22. And the point negative 3 comma 19, which is about here. The point negative 4 comma 10, about here. The point 0 comma 10, right there. Okay, so let's sketch the left half of the parabola. And knowing that this dotted line, x equals negative 2, is the axis of symmetry, we know that the right half of the parabola, the part of the parabola to the right of the dotted line x equals negative 2, is going to be a mirror image of the left half of the parabola on the left side of the dotted line x equals negative 2. So each point in the left half of the parabola gets reflected on the dotted line. So let's take the point -3, 19, which is 1 to the left of the dotted line. So reflecting it on the dotted line, we're going to get a point 1 to the right of the dotted line. So that's going to be the point -1, 19, right there. And then taking the point -4, 10 right here, which is 2 to the left of the axis of symmetry, the dotted line, and reflecting that in the opposite direction, we get a point 2 to the right of that dotted line, which coincidentally has already been plotted, 0, 10. And now let's connect those points. And we don't know exactly where it crosses the x-axis because you haven't learned the quadratic formula yet. And the equation y equals -3x squared minus 12x plus 10 is probably not factorable. So let's not worry about getting the exact x-intercept. So let's just extend the parabola, draw an arrow to indicate it goes on forever in the other direction. All right, now let's look at a word problem, last example problem. Example 4, find the minimum value of a function. The suspension cables between the two towers of the Mackinac Bridge in Michigan form a parabola that can be modeled by the graph of y equals 0.000097x squared minus 0.37x plus 549, where x and y are measured in feet. What is the height of the cable above the water at its lowest point? All right, so I'm just going to make a little sketch of the bridge to help you understand what's going on here. It's a suspension bridge. We have two towers of the bridge right here and here. And here's the horizontal part of the bridge, the road. And suspension cables. This parabola, the suspension cables, can be modeled by the function y equals 0.4097x squared minus 0.37x plus 549, and x and y are measured in feet. And y is the height, x is horizontal distance. Okay, let's find the lowest point, the height of the cable above the water at its lowest point, right here. And here's the water. The x-coordinate can be found by the formula x equals -b over 2a. That also gives you the equation of the vertical axis of symmetry. Substituting in, that's going to be negative 0.37 over 2 times 0.000097. And if you put all this in a calculator, you're going to get 1,910. The lowest point is 1,910 feet to the right of some arbitrary point that they chose. Well, okay, it looks like they're considering the horizontal position of the tower on the left to be at x equals 0. All right, now to find the height the y coordinate of the lowest point, we substitute in 1,910 in for x in the original equation. So that's y equals 0.000097 times 1,910 squared minus 0.37 times 1,910 plus 549. And if you put that into a calculator, that's going to be y equals 196 feet. So this lowest point here of the suspension cables is 196 feet above the water, and 1,910 feet to the right of the left